All right, here we go again. We have a couple examples of solving exponential equations. So those would be equations where the variable is in the exponent spot. They're very simple to do as long as you know how logarithms work. So let's just get at it, right? So here's an example. First example, maybe I'll do two of these, but the first example I'm going to make is going to be very crazy. 3 times 4 to the 2x power minus 2.1 equals, I don't know, 11.2. That's craziness, okay? Goal is you want to get x by itself, so you got to isolate. This is like a normal equation solving problem. You want to save that for later, so we're going to let it go because you want to do those exponents at the end because it's like reverse order of operations. So the first thing you're going to undo is the subtraction by adding 2.1, and we're going to get 3 times 4 to the 2x equals 13.3. All right, we're still not going to work on that 2x yet. We're going to get rid of the 3 next with division. You're going to save that exponent for the end. We're going to divide that out. We're going to get 4 to the 2x equals 13.3 divided by 3. Okay, we're going to lose some accuracy here, so you're going to want to round off as best as you can. I like to choose at least 3 decimals when I'm doing this, thousandths place. We're going to get that, and now we're stuck a little bit. We have an in the exponent. We don't want it there. So what I would do at this point is literally you're going to take the log of both sides. Okay, that's going, and we're going to leave base 10 on that log. We're not going to put anything in there. So that's going to allow you to use your exponent rule, which allows you to move the exponent to the front of the log. So we will go and write it as a coefficient. And now it's not there anymore. All right, one thing you should notice, if it's just x, you're in good shape. But if there is a 2 there, a really good idea, you don't have to do this, but what you really probably would rather do is now take that 2 and put it back inside and get x log, and that's going to be 4 squared, so we're going to get 16. That's another power rule right there. Ideally right here, you would have noticed that we could just write that as 4 to the second power. We could have made that 16 to the x right away. It would have saved us this step. But if you didn't, there it is. And if you leave the 2x out there, it's not a big deal. It's just kind of uglier. So now all you want to do is get this x by itself. So you are literally going to divide the log. Anytime you can avoid taking logs and rounding off to their decimal places, you should do so. Okay, so if you can keep it in log form, that's much better because you don't lose the accuracy. So we're going to divide these. You're going to have to wait while I put this in my calculator. Downtime. All right. I arrived at 0.53707. And that would be the answer that would make this problem work. Okay? All right, I'm going to do one more where we have an x value on both sides, and then we will move on to the next portion. Here, you need some. Hey, that looks good. That's a good answer. Nice job. All right, nice job. See you later. Don't ask me. I don't know what I'm doing. All right. So one more example, and then we'll call it a day on this. We will do 2 to the x plus 1 equals 3 to the 2x. And we have to find an x value that makes both of those work. These have an x on both sides, so right away you are going to write the log of both sides. Ta-da. Great. And now use your power rule again. The x plus 1 here can be moved to the front. You're going to want to make sure you put parentheses around those. So we're going to write parentheses x plus 1 times log 2 because you have to distribute it all the way through. And then let's talk about the last one we did before. We said we could have saved ourselves some time if we would have made this log of 9 to the x because 3 squared is 9. So I'm going to do that this time. All right. So distribute the x. We're going to get x log 2. and then distribute the 1. So we're going x times that and 1 times that, and it's going to be plus 1 log 2. I'm not going to write the 1, but it's there. And now I'm going to move that x to the front because I need it there. X log 9. Now you have two options here. You can take your calculator, you can type in the log of 2, the log of 2, the log of 9, and you're going to get a bunch of decimals, and you can solve it like a normal two-step equation. But if you want to keep it accurate, you try to keep these as logs as long as possible. So what I'm going to do is I'm going to gather up the x's to one side, so I'm going to subtract x log 2. That's better. So we're going to get log of 2 on the left, and we're going to get x log 9 minus x log 2. Okay, and we have an x in both of those terms, so we can factor it out and write log of 9 minus log of 2. And all I'm doing is removing the x from both of these, and I'm basically factoring it out. So when I remove the x from here, I get log of 9. When I remove the x from here, I get a log of 2. We're dividing that x out. All right, cool. And showing off more of your knowledge of your fancy rules, when you subtract two logs, you can condense them into one log by dividing their insides. So that's actually the best way you can do this problem. And then to get x by itself, now we finally divide at the end. So it's a whole big mess of stuff to put into your calculator. So you got to be very careful. You're going to do the log of 2 divided by the log of 9/2. And you're going to be very careful to use a lot of parentheses. And you should come up with this answer. X equals 0.461 approximately. And then you can impress your friends at parties by showing them that you know how to do this, and they don't. Alrighty, so there's a couple examples on logarithms, and like I said, the other way we could have done this from this point right here, you could have taken a calculator and done the log of 2, got a decimal, done this. You could have computed this log, and did decimals with those, and it would go together, but this is a better answer than that. So, all right, bye.